All right, so we have an iPad connected to a keyboard, and that's going to represent intersecting planes. And we're going to learn more about intersecting planes in our lessons today. But all we needed to do was answer true, false. In geometry, we love true, false questions, and we love always, sometimes, never questions. So get ready. They're lots of fun. So what I would do first is, especially if I was doing this on a worksheet, I would bold the points that they're asking about. For example, A, F, and E. A, F, and E. They are either collinear or they're non-collinear. What do y'all think? A, F, and E. We're doing number one. Yep, they are not collinear. So to say they're collinear is an atrocity. It is false. Collinear, let me remind you, means I could draw a line through them. Could I draw a line, a straight line, all lines are straight, through those 3 points? No, I could not. I could draw a curve, but I could not draw a line. So let's move on. Points B, C, and D are non-collinear. Is that a true statement or a false statement? You were ready with it. I think y'all had already typed it. You wanted to be the first one. That is true. They are non-collinear. All right, let's erase some things. Points A, D, and C. A, D, and C are coplanar. Are they in the same plane? Well, they're all in the plane of the iPad. I could put a flat surface through all 3 of those. So yes, they are coplanar. Points B, D, and G. B, D, and G are coplanar. Number 4 is the trickiest one on the warm-ups today. Instead of thinking of coplanar as they're in the same plane already, I want you to think of coplanar as I could put a plane through them. I could put a flat surface through B, D, and G. So is that true or false? I could put a plane through them. Well, there it is. There's my plane. Dun, da, da, da. I found one. So believe it or not, that is actually true. But if you got that one wrong, that's okay because it was tricky and we haven't really discussed it yet. Yeah, welcome to Geometry K. All right, last one. Points F, E, D, and A are non-coplanar. Now here's the thing. I could put a plane through AFE or through FDE, but I couldn't put a plane through all 4 of them. I could catch 3 of them, but I couldn't catch all 4 of them. So that is actually true. They are non-coplanar. Now normally I would call on your names and I would make you answer the warm-up questions, but for now we're still kind of getting used to things. So yesterday we filled out a vocab sheet. And that is your new best friend because you need to make friends with your vocab sheet with all of the words. There were 19 words on there. And so I want to go into a little bit more depth. Yes, we have a test on the 3rd week of school. I want to go a little bit more in depth of how you would write all of these things if you were writing a sentence. So this is like math language. I'm going to translate English into math language. So let me show you how you write each one of these things. How do you write a point? Well, it says on your vocab sheet that you should have looked at last night that a point is named with a capital letter. So I'm going to pick a capital letter. I'm going to pick T for Tanton. That's how you name a point. How do you name a line? You name a line with 2 capital letters with a line on top. So here's how you name a line. A plane. Your paper says how to name a plane. You name a plane with 3 capital letters, like RVU, there's an example. Or every now and then, you can name a plane with an italicized letter if that plane has one, like this. If it has an italicized letter in the corner, You can call it plane M. But we don't do that very often, but I needed you to see that. Segment, how do you name a segment? Capital letters with a segment on top. 2 capital letters for the 2 endpoints. How do you name a ray? 2 capital letters with a ray above them. 1 arrow only, that's how you name a ray. What's the symbol for congruent? An equal sign with a squiggly on top. What's the symbol for parallel? 2 bars like this. And then what's the symbol for perpendicular? The symbol for perpendicular is an upside down T. So some of these you might have already known, some of these might be brand new. If you didn't get a chance to write this down, if this was new to you, you can watch the recorded lesson and push pause when I get to this slide and you can stare at it as long as you want. But I did just want to go over some things, some symbols that you may or may not have known. Okay. We did go over this yesterday, correct? Yes, notation? This is an object, so we use congruent with it. This is a number, so we use equals with it. Yes, the worksheet's going to be homework, Alton. Yes. What school are you with, Alton? You need to put your school first. Okay. All right, we are going to be translators. And I wish you all had your cameras plugged in and you could talk, but logistically that would be kind of crazy. But we can take turns, each school plugging a camera in every now and then, so that y'all have time to, so that y'all are able to answer questions and talk. So what we're going to do is I want you to say out loud at your school, and I can't hear you, but I want you to say the name of number 1. What is number 1? And I want you to say it out loud. Go. What is number 1? Say it in English. Hopefully you said, yeah, hopefully everyone said line MT. Because I put a line over it and I used 2 letters, it was line MT. We're going to come back to number 2. Everyone do number 3. Say number 3 out loud to your neighbor. Go. Ray XY. Very good. The next one, I don't know why that fell down like that. Pretend it's a little bit higher. The next one is segment HV. What's the next one? Number 5. Say number 5 to your neighbor. If I just use 1 capital letter, it's a point. All right, let's move on to number 6. A lowercase italicized letter. Let me show you what that would look like. Once again, we don't do this very often. Every now and then, that's line AB, but if they put an italicized lowercase letter, you could also call it line italicized M. But like I said, it won't happen often. I just wanted to show you. All right. Oh, number 7. Number 7, that's a whole sentence. Say that sentence to your neighbor. Hopefully you said line GH is parallel to line IJ. See that? Isn't that so cool that in math we get to be lazy and we get to just use symbols instead of actually writing out all those words every time? I love math. Okay, next one. Oops. Say number 8 to your neighbor. Say number 8. Segment OK is congruent to segment RA. You doing okay, guys? Last one, number 9. Line ME is perpendicular to line YU. Me is perpendicular to you. Huh. So funny. All right. Cool. So now if you have this sheet of paper, you would get this out at this time. If you don't have it, it's no big deal. We are going to learn the 4 basic terms, or not terms, postulates of geometry. So we're going to learn the foundation of geometry today. The 4 things that everything in geometry is built off of. That's what we're learning today. And there's 4 postulates that we're going to go over. You don't need to memorize which number the postulate is, but you just need to understand what the postulate means, okay? First, we're going to figure out how many points create a unique line. So, if I grabbed one of these points, if I grabbed this point right here, how many lines could I put through that point? How many lines could I draw through that point? 1, 2, 3, 4, 5, 6. When would I ever stop? I can draw this one, and then this one, and this one, and this one, and this one, and I could stand here for the rest of my life because lines have no thickness. So you could go on forever and ever and ever. So through any one point, there's an infinite number of lines. So 1 point does not create a unique line. Okay? Well, now let's try 2. Will 2 points create a unique line? There's 2 points. I'm going to put this line through both of them maybe. How many more lines could I draw through those 2 points? How many more? Unique lines. No more. Very good. So how many points does it take to create a unique line? 2. Dos. So that is postulate number 1. Through any 2 points, there is exactly 1 line. There's not a half a line or 5 lines or 100 lines. Through any 2 points, there is exactly 1 line. Lars, you're giving it away. Don't type that. So that's postulate number 1. Write down the postulate. You can sketch a quick picture if you want. What do you get when 2 lines intersect? This one you're going to be like, this is common sense. Why is this a postulate? This is common sense. So when 2 lines intersect, what's that called? What's at their intersection? What basic geometric term? Yeah, they cross, but what object is at the intersection? Do they intersect in a plane? Do they intersect in another line? They intersect in a... Oh, yep. Point. When 2 lines cross, you get a point. So that's the second postulate. If 2 lines intersect, they intersect in exactly 1 point. Can they intersect again later down the road? Can those 2 lines meet up again later? No, because lines can't bend. So if 2 lines are going to intersect, they're going to intersect in 1 point and only 1 point. They can't intersect twice or 3 times. Now, they can intersect 0 times. They can intersect 0 times, but they can't intersect 2 times or 4 times. Good. Moving on. So we figured out when 2 lines intersect, you get a point. What do you get when 2 planes intersect? Yeah, totally. When 2 planes decide to cross, they're going to cross in a line. So that is postulate number 3. 3 down, 1 to go. Woo! If 2 planes intersect, they intersect in exactly 1 line. Can planes intersect 0 times? Can planes be parallel? Sure. 2 planes can be parallel, but if they do decide to intersect, you're going to get a line. Can planes be skew? Do you know enough about what skew is yet to know if planes can be skew? I'm going to let you think about that one. I'm going to let you think about it. I'm going to let you look it up. Can't give you all the answers. Plane. Okay, so we went over vocab yesterday, and a plane is a flat surface that extends in all directions forever. So think of a plane like a sheet of paper. Think of a plane like the ceiling. Think of a plane like the smartboard. It's a plane. It's a flat surface. So I want to know how many points it takes to define a unique plane. Is if I've got 1 point, I know I'm fading, if I've got 1 point, I can create all sorts of planes. Look, I can rotate this. Infinite number of planes can go through 1 point. But what about 2 points? Can I get a unique plane if I use 2 points? Let's try. Now I've got 2 points. Boom, there's a plane. But wait a minute, I can rotate it, and I'm not losing either of my points. I'm still touching both of my points. So 2 points won't cut it. I need another writing utensil. What about 3 points? Going to grab, oh, there we go. There were the ones I used last period. Okay, once I have 3 points, 1, 2, 3, I usually ask a student to come up and help me. Boom. Once I have 3 points, look, if I rotate it, oh, I just lost my purple pen. Oh, I just lost my Sharpie. Oh, I just lost my black pen. If I try to rotate it with 3 points, I'm going to lose a point every time I try to rotate it. 3 points means I'm locked. I'm locked there. I can't rotate it. So you're all correct. You are all saying 3 points, and you are correct. It takes 3 points to define a plane. And so I brought my handy dandy tripod with me to show you, because why is it called a tripod? Why isn't it called a quad pod? Why didn't they give it 4 legs? Why didn't they give it 2 legs? What would happen if they gave a tripod 2 legs? It would fall over, right? And then if they gave it 4 legs, 3 of the legs might be touching the ground and the other one might not, so it could wobble. But 3 is the most stable that it could possibly be, because 3 points define a plane. 3 points can all touch the ground at once. Have you ever sat in a chair or a desk that wobbled? Have you ever? It's probably because it had 4 legs. If it had 3 legs, it wouldn't really wobble. Okay. Why does that word non-collinear need to be in there? If you took a tripod, this one is not going to let me do it, but if you took a tripod and you put all 3 of these in a row, you lined them up, they're collinear, the tripod would fall over, right? If they were all 3 of the legs were in a row. So that's why they have to be non-collinear points, okay? Okay. Oh, there we go. There's my example. This one, oh my goodness, please don't let me sit down in that one. That one could totally fall backwards. This one is the most stable. And this one, most chairs do have 4 legs, I agree. But there is the potential to wobble, because 3 of those might be in the plane of the floor and the other one might not. So hopefully that visual will help you. So here's what we learned. Through any 2 points, there is exactly 1 line. Through any 2 points, there is 1 line. If 2 lines intersect, you get a point. If 2 planes intersect, you get a line. And through any 3 non-collinear points, there is exactly 1 plane. So those are the building blocks, the foundation of geometry. This is when I would... All right, sorry, I had to reveal the next ones to extend the page, but we're on number 4. 2 points, 2 planes, blank, intersect in exactly 1 point. Ooh. 2 planes, always, sometimes, or never, intersect in 1 point. That's one of our postulates, guys. What do we get when 2 planes intersect? We get a line. So when are they ever going to intersect in a point? Wow, well that's never. Oh, that's okay if yours isn't the same as on the back. We weren't doing this on the back yet. We were just doing whiteboard problems. Sorry. Okay. A plane containing 2 points of a line, always, sometimes, or never, contains the entire line. If you contain 2 points of a line, are you going to contain the entire line? Always, sometimes, or never. Yep, because remember, it takes 2 points to make a line. So once you've got your 2 points, you're set, you're stuck. You've got a line. You can't tilt it at all or you'll lose one of your points. So once you've got 2 points, you have a line. So that's always. 2 lines blank meet in more than 1 point. Ooh. 2 lines always, sometimes, or never meet in more than 1 point. So parallel lines meet in 0 points, you're right, but is 0 more than 1? No. So they can meet in 0 points, they can meet in 1 point. Do we have any other choices? They can meet 0 times or 1 time. Never. Never meet in more than 1 point. Okay. This was on the back of your worksheet, but I know that you were saying, some of y'all are saying that your bell is ringing. I'm going to finish this one right here, but everyone, if your bell rang, just do that worksheet for homework, and I'll show you the answers tomorrow. Okay, this is on the back of your postulate sheet. Name the intersection of the planes GCB, GCB, and ABC. So that's this plane right here and the bottom right here. Well, we just learned that when 2 planes intersect, you get a line. So our answer to this question better be a line. So the answer is line BC. Name a 4th point in the plane EFB. EFB. Whoa. That's a plane like shooting through my box. Do you see that plane? It's like shooting through the box. It's a diagonal plane. So the 4th point in that plane would be C. Okay, that's all I have for you guys today. You're going to do your homework, which looks like this. Basic geometric terms.